everyone, I hope you all are doing extremely amazing and I hope your IMAT 2025 went extremely well. So I hope you all ace your exam with a very good score in your IMAT 2025. So now in this lecture, in this video, we will be discussing about some of the questions which are present in your IMAT examination along with their detailed explanation answers. So without any further ado, we will be discussing the questions super soon. Alongside that, while discussing the questions, I will also give you a little bit analysis of how the questions were there, how was the examination pattern this year according to chemistry, and how it has changed from the previous year, right? So on a very core rule, we can see that the questions which were present in your examination were on a moderate side, were from easy to moderate. Only few questions were there which can consider to be a little bit hard, but mostly it was on easy to moderate side as compared to the past few years. So we can just check out from the last 2 years, this question paper is seemed to be a little bit much easier as compared to the previous year. So we can start up with the questions. Alongside that, I will be giving you a little bit idea upon the same. So without any further ado, let's start with our video. So we can see the very first question on your screen. This question is basically from the states of matter, in which we usually discuss the laws, the Boyle's law, the Boyle's law, Charles' law, all such type of laws which we usually discuss in that states of matter. In that, we also discuss one of the equations, right? We discuss one of the equations which is known as the ideal gas equations, right? This ideal gas equation actually gives for the ideal gas, right? These are present for the ideal gas, and this equation is a very simple, in a simple normal term, in a definition we say it's PV is equals to nRT, where P is the pressure, V is the volume, N is the number of moles of the gas molecules which are taking, R is the gas constant, and T remains the temperature. So this equation is your ideal gas equation, which is very, very important, which we usually said as well when it was done. So from the gas laws, this question considered to be very, very easy, because they could have given you the questions on Boyle's law or Charles' law, right? Even the combined gas law, but just asking for an equation is a little bit easy question, right? So we can say it's PV is equals to nRT. Option A is your correct answer. So I hope this question is very, very clear. Let's go to the next question. In which of these compounds does chlorine have the oxidation number of +3? So this question is basically from your redox reactions, in which we usually discuss about the oxidation numbers, or we can say the oxidation states. Now the thing is, in this chapter we have many topics, like we have balancing, we have different types of balancing and everything like that in the acidic medium, in the basic medium. Even in the previous year when we usually discuss about oxidation number, questions were on the regular pattern. Alongside that, balancing questions also used to come. So this time they have just given a very simple question in which you have to calculate the balancing, what we can say, the oxidation number, right? And we know the oxidation number can be calculated very easily. For example, we have HClO2, right? HClO, we know that the valency of hydrogen means when we calculate the oxidation number, how the oxidation number is calculated, we consider the bond to be ionic, and we consider it, we pretend the bond to be ionic, we break it and consider the charges upon them, right? According to that, it gets a +1 charge, oxygen has a -2. So what about chlorine? Let it be X. So it will be +1 plus X minus 2 into 2, because 2 atoms is equals to 0, because no charge is there on the entire molecule. So it will be like +1 plus X minus 4 is equals to 0, X comes out to be +3. So the very first option only is getting to your answer, that is +3. With the rest, you can check that we know that whenever chlorine is in the elemental form, elemental or the molecular form, means in the natural state. Chlorine in the natural state exists as Cl2 gas. Now since it is existing as Cl2 gas, its oxidation state would be 0. Similarly for HCl, it would be -1. For HClO, it would be how much? +1 for hydrogen, Cl to be X, oxygen to be -2. So it will be is equals to 0. +1 plus X -2 is equals to 0. We can say it is -1 plus X is equals to 0. X comes out to be +1. So here it would be +1. Similarly, HClO3, it would have been a different value you can calculate. So we can say it would be +1 plus X minus 6 is equals to 0. X comes out to be +5. So according to the conditions and terms, this question was also considered to be an easy one, right? This is also an easy one question. Why? So because here, instead of giving you asking the oxidation state for the, sometimes we take oxygen has to be in the -1 oxidation state, right? But here we know that this is in the -2 only. So like this, we can clearly see that your answer is completely correct. Let's go to the next one. Now the 35th is an oxidation number cannot be. So it's kind of again from the redox reaction, and it's a kind of a theoretical question, a factual question in which we usually state the facts that oxidation number can be this or that or whatever, right? So now oxidation number cannot be. We know oxidation number, when we talk about the oxidation number, we know this value can be positive. Like for example, hydrogen it is +1. This value can be negative. For chlorine it comes out to be the -1. Oxygen it is -2, right? This oxidation number can also have value of 0. For example, we have Cl2. It is the 0 in the oxidation state. N2H2, 0 oxidation states, right? Now when we talk about the fraction or the decimals, although it is not much common, right? It is not much common, but some of the elements are there which exist in a fractional oxidation state. They exist in a rational number oxidation state, means in a fraction, p/q form. So we can say they exist in a decimal, although this is not a general rule. Only under certain conditions, some of the elements exist in this. For example, we have some iron oxides. Iron oxides, in some of the cases, they usually show the decimal oxidation states, the we can say the fractional oxidation states, right? But we can say the irrational number can never be. It can never be. An oxidation number can never be an irrational number like a pi, 3.14 or whatever. But fraction, we can also say it can exist. Although this question was a little bit confusing one, because student would have been confused between option A and option D actually, because we usually generally never consider those questions in which the oxidation states are taken to be in the decimal state, right? But because here we have given the option between the decimal as well as the irrational number, so decimal conditions are applied only for a few, 1 out of million number of cases. So only for a few number of cases the oxidation state can be in decimal, but it can never be irrational. Option number A would have been correct over here, right? And option number D would be wrong only. Also, it can all in the states, but in the irrational number it can never be. So we can clearly say that the oxidation number question is done like that. So from this, I can make a little bit conclusion that from redox reactions till now, 2 questions we have done. One is directly calculating the oxidation state of a particular element, and the second is we are discussing the oxidation states, the rules, right? The oxidation state can be positive, negative or whatever. So such type of rules is basically asked in the questions. Okay, so according to this, through this question, we can clearly understand that the oxidation numbers, right? The oxidation number, the values of oxidation number also hold some values, because they can be asked in your question as well. Next is, what kind of a solid is NaCl? So this was a very easy question for you people. So this question was considered to be very easy, because we clearly know that this is a type of an ionic solid. Why? Because this bond is formed between a metal and a non-metal. So we know whenever a metal and a non-metal makes a bond, metal loses up the electron and non-metal gain the electron. So we can clearly see that here the loss and gain of electron is taking place. So it means the formation of ions will take place, and ultimately an ionic bond will be formed. Whereas in a covalent bond, what happens is, in the covalent bond we usually share the pair of electrons. So this is also a very simple question which was not given directly in your previous year questions, but in the previous year what happened was, they have given you in these type of questions in some sort of relationships, means they asked you the polarity, right? In the covalent bonds, in the ionic bonds, what are their polarities and everything. In the previous year, polarities was considered according to these questions, and in this year they gave you the direct question, like NaCl is which kind of a solid. Let's go to the next one. So the next one is, in the periodic table the atomic radius increases. So okay, this is also a very simple question. This is a very first trend which we usually discuss in the periodic table. Now we know when we go from left to right in the periodic table is somewhat like this, right? This is like this. Now when we go from left to right in a periodic table, this is the left, this is the right part. When we go from left to right in a periodic table, and when we go from top to bottom in a periodic table, right? Whenever we study this chapter of periodic table, the very first trend comes in the syllabus is the atomic size, or we can say the atomic radius. Now we know when we go from left to right in the periodic table, the nuclear charge increases. If the nuclear charge will increase, what will happen? The outermost electrons will feel much attracted towards the nucleus and their size will ultimately decrease. But when we go from top to bottom, the number of shells increase. If the number of shells will increase, the outermost electrons would not feel much of the attraction from the nucleus, right? So we can say the number of shells are increasing, the size will ultimately increase when we go from top to bottom in a periodic table. So now you can see when we go from left to right, the size increases. When you go from right to left, when you're going from right to left, the size increases. When you go from left to right, the size decreases. So here the size decreases, here the size increases. Similarly, top to bottom, the size increases. So opposite we are just going. So you can just look into the option and you can get onto the answer that it is from right to left and top to bottom. Option number A is correct, that when you are going from right to left in a periodic table, the size is increasing. Top to bottom, you're going, the size is increasing. I hope this question is getting clear to you, how the trends in the periodic table is taken with respect to the atomic radius. So alongside that, in the previous year, they have given you some questions like we have the charges, we have Al3 positive, we have Zn2 positive, and they were asking you about their sizes. So we know more the charge, more will be the size, lesser will be the size. More the positive charge, lesser will be the size. We know this thing. So this would be much bigger as compared to this. So in the previous year, they have given you the questions on the basis of the charges in the periodic table, and here they have given you the questions directly on the normal trend. So this was also a very easy question. Next we can see is 38th question. A pure covalent bond is a bond that forms between. Okay, so now this is another question from the chemical bonding. Like the first question came from ionic bond and the second question is coming from the covalent. The first question came from the ionic bonding and the second question here we can see is from the covalent bonding. It means from the redox reaction 2 questions were there, and from the chemical bonding 2 questions were there in your syllabus, in your exam actually. So now we have a pure covalent bond. Now we know that a covalent bond is formed when there is sharing of electrons. When the electrons are sharing, the covalent bond is obtained. We know this very clearly. That when the sharing of electron is done, the bond is formed. The bond formed is actually covalent bond. But now covalent bond was also of 2 types. It was polar covalent and it was non-polar covalent. And what do you mean by a pure covalent bond? Pure covalent bond means when there is a complete sharing of electrons, no electronegativity difference, nothing is there. For example, oxygen and oxygen are there. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have 6 outermost electrons, both require 2 electrons each. So it will become 8, it will become 8. Octet of both the oxygen will be done, completely done, right? Both are completely stable. Both are equal in electronegativities. Both are having equal electronegativities, right? They have not even a slight difference, because if the slight difference even arises, they generate a polar charges, right? They generate a polarity, partial polarity they generate. Even in the covalent bond, we know, for example, HCl, right? The partial polarity is generated over here. So here this is not a purely covalent bond, it's a polar covalent bond. But when we talk about a pure covalent bond, it means it is 100% sharing of electrons between 2 atoms which are nearly the same, exactly the same, not even nearly, exactly the same. So we can say it is the 2 atoms of the same element, we can say, having the reaction between the pure covalent bond is being formed. So next is 39th. The pH of the aqueous solution of monoprotic weak acid is this and concentration is this. So this is the equation and here you need to calculate the pH. Now it was given a weak acid, right? Acid base equilibria, weak acid. We have a weak acid, it will partially break down into H positive and A negative. We will solve this question. Even in the previous year, such kind of questions were directly there, and the same question, same type of question is coming here. There, what they did was, they gave you the weak acid or a weak base, they asked you about the pOH, right? And here they're asking about pH. So this question was exactly coming from the previous patterns. So what's happening here is the initial concentration given to be 0.001. It was 0, it was 0. Now at time t, means at equilibrium it will be 0.001 minus x. This will be x and x. So I will write the equilibrium constant. It will be H positive, it will be A negative, it will be HA. So it will be x into x divided by 0.001 minus x. And we know that since this is a weak acid, so this dissociation will be very, very less than 0.001. So we can neglect this x in the denominator, and Ka value is given in the question. 1.0 into 10 to the power negative 5 is equals to x square upon 0.001. So now solving it, 1.0 into 10 to the power negative 5 into 0.001 is equals to x square. You will be getting it as 1.0 into 10 to the power negative 4 is equals to x. Right, now x value you got means the H positive ion concentration you got. So we can say that the H positive ion concentration is equals to 1.0 into 10 to the power negative 4. Now pH is equals to minus log of H positive. So you can just put pH is equals to minus log of 1.0 into 10 to the power negative 4. Your pH comes out to be positive 4. I hope this question is clear. So we can clearly see this is a very simple question from the previous pattern that is coming directly from previous year questions. We can see the pattern of such type of questions is continuing. We can go with the next question. Okay, so the next question is, what is the pH of a 0.7 molar aqueous solution of KBr? So now when we talk about KBr is a salt. This is a salt which is obtained from a strong acid and a strong base. How come? This is a salt which is formed from KOH plus HBr. This is a strong base and this is a strong acid. And we know that whenever a strong acid and a strong base is dissolved, what happens? It will give me a pH which is equal to neutral, right? It will give me a neutral pH, and neutral pH is considered to be as 7. So you can see that from the acid base equilibria, two types of questions were there. The very first question included that the pH of the solution, in both the cases you have to actually calculate the pH only, and even when you will find out the analysis from the previous year papers, you are about to calculate the pH from the various questions which are present in your previous year. They were giving you certain equations for the weak acid, for the weak base. They will ask you to find the pH with the pKa value, right? These type of questions were there in your previous year, but this time the questions were much more on the easier end. Instead of finding for the Ka and the pKa values, they just directly give you the values and you have to just put it into the equations and you'll be getting your answers out of it. So you can clearly see the question level. This one I would say it is a moderate question, because many of the students would have been taken time of actually calculating the pH. Many of the students would have used this concentration. And calculated the pH or something like that. But actually you just have to kept in your mind that this is KBr, that is a salt of a strong acid as well as a strong base, which will when ultimately mix up, they will not really lead to the formation of the H positive and the OH negative ions of water, right? That is why we can say the pH will remain 7 in this case. So I hope this question is clear. Let's go to the next question. Given the equilibrium, heat FeCl3, FeCl2, Cl2, which of the following option is correct? So it's completely seen that is FeCl3. We are heating it, giving me FeCl2 and Cl2. So this is gas, this is solid, and this is solid. We know that according to the Le-Chatelier principle, the concentration depends, right? Now, the equilibrium will be majorly affected by the gaseous reactants or the products. It will not be much affected by the solid, right? Because we know that the solid concentration is nearly taken to be the same. So we can see that the shift the equilibrium to the left if it is necessary to increase the concentration of Cl2. We know if the concentration of Cl2 will increase, equilibrium will go towards the left according to the Le-Chatelier principle, because Cl2 is in the product side on the right hand side. If it will increase, equilibrium will go to the left hand side. To shift the equilibrium to the left, it is necessary to increase the concentration of FeCl2 solid. So we know that this is a solid product, right? So its concentration which may not affect the direction of the equilibrium. The shift equilibrium to the left, it is necessary to remove FeCl3. So that is completely wrong. If you will remove FeCl3, how come the equilibrium will shift towards the left? It will go towards the right hand side. To shift the equilibrium to the right, it's necessary to cool the reaction. How to cool this reaction? This is an endothermic reaction. So it does not even occur when you are just cooling it. To shift the equilibrium to the right, necessary to increase the concentration of FeCl3 solid. So again, it is a solid, so it may not affect much to the equilibrium concentrations, direction of the equilibrium. So this was a moderate question according to the basis of the Lee-Chatelier. So we can say the option number A is correct in this question. Next, the activation energy of the reaction represents. So we know that when a reactant is there and when we go towards the products, right, a certain transition states comes, and here energy, here is the reaction coordinates. Here we get a certain energy which is known as the activation energy. Even in the previous year questions, you can see the question on catalysts have come, the question on activation energy has come, right? Similarly here also, even the rate of reaction questions have come from the chemical kinetics in your previous year question papers. If you will just look into the past 2 years question papers, the rate of reaction questions have been there, but this time they have just given a question very simple, very moderate from the activation energy. It is more on the easier side actually, not even on the moderate side, because we know what is activation energy. Activation energy means energy required by the reactant to initiate a reaction. It means it is the transition energy required for the reactant to get into the transition state so that it can ultimately get into the product. So we can say that it is the difference between the energy of the products and the reactants. No energy barrier over to form the products. So exactly we can see that option number A is getting here correct, the energy barrier that reactants must overcome to transform into the product. So this is known as our activation energy. I hope this thing is clear. So let's go to the next question. Next we have in benzene. So this is a very simple questions from your organic chemistry. So hybridization question it is. So we can say this is benzene. This is benzene in which each carbon atom is sp2 hybridized. We know this thing that because it has we have one single bond. For example, we have carbon, 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 carbon like this. We have hydrogen like this. We have hydrogen. And we have hydrogen, we have hydrogen, we have hydrogen, we have hydrogen. So we can see a carbon is making what? Carbon is basically getting sp2 hybridized. Why so? Because it has 1, 2, 3 sigma bonds and 1 is the pi bond. So we know it is sp2 hybridized. Each carbon atom is sp2 hybridized. Now if it is sp2 hybridized, we know, so we know that hybridization sp2 corresponds to the planar structures. So we can clearly see it is sp2 hybridized and the molecule has a planar structure. So all the carbon atoms are sp2 and it is having a planar structure. This option is incorrect because it is sp2. This option is sp2 but it has a chair and boat structure, which is not correct. It is actually in the presence of cyclohexane, not in the case of benzene that is having a boat or a chair structure. And 3 carbon atoms are sp3 and rest are sp2, which is also incorrect. Next is question number 44. We have glycogen. We know that glycogen is actually a homopolysaccharide. Why it is a homopolysaccharide? Because it is a polysaccharide which is made up of only glucose units. It is only made up of glucose units, not other units at all. Means it is the homopolysaccharides which is made up of only the glucose subunits. Means only one type of monomer is present, which is glucose, right? Heteropolysaccharides means when we have more than one type of monomers, right? And the disaccharide is just like sucrose, which is made up of 2 polymers. For example, glucose and fructose are actually combining to give me sucrose. A storage molecule in both plants and animals. See, glycogen is basically a storage product of animals, not plants, right? Next, it's a polypeptide, which is completely wrong because it is a carbohydrate. It is not a polypeptide, it's a carbohydrate. So I hope this question is clear. Option number A. Next, we have the compound FeCO3. So here it is just a name of this compound FeCO3. What do you mean by the name of FeCO3? We know that FeCO3 is there, right? So here Fe is in which oxidation state? Because we know CO3 2 negative, so Fe must be in 2 positive oxidation state, right? Then only it become ultimately neutral and it is coming out to be FeCO3. And Fe2 positive is also known as ferrous, right? So we can say this is known as ferrous carbonate. So this was a very simple question which was not there in your previous years, and in the IUPAC, or when we say in the nomenclature, the questions comes out to be a little bit more advanced, but this is a very easy question which has been there. So it's ferrous carbonate. Only one thing which you have to keep in mind here is you have to just check out the charge on the iron, right? So if it would have been Fe3 positive, then it would have become ferric, but now it is Fe2 positive, so it has become ferrous. I hope this thing is clear. Now, how many electrons can occupy an orbital? So this is a very simple question, that one orbital can occupy only 2 electrons, that too in the anti-parallel spins. So rest of the options are incorrect. Next, which of the following statement about amino acids is true? Now, amino acids, what do you mean by amino acids? Amino acid structure is somewhat like this. This is a structure of such kind of amino acids which have an amine group and which have an acidic group. We know this thing, right? Now they contain an amine group and the carboxyl group, which is completely correct. They are normally poor soluble in water. No, this is wrong. Amino acids are basically polar. They are polar because they form Zwitter ions. They form Zwitter ions. When this gains up 1, it forms NH3 positive, and it forms C double bond or COO negative. It forms, it's a Zwitter ion forms. When Zwitter ion form, they become polar. They become more soluble in water. There are polarities there, right? So this is completely wrong. They dissolve in hexane. It is wrong because hexane is a non-polar, and polar things cannot be dissolved in non-polar substances. They are one of the main constituents of carbohydrates. No, they are the main constituents of proteins, not the carbohydrates. They have no acid base activity, which is wrong because it has a basic group and as well as a acidic group. So we can say option A is the only correct answer. So like this, we have discussed all of your questions of your IMAT 2025. I hope the questions were well clear to you. The question paper was on a very moderate to easy side. Only 1 to 2 questions were there in which you have to actually think upon the concepts or anything. Otherwise, all the questions were very direct as compared to the previous years. In the previous year, we could have seen the questions length were more, right? They have been asked for the more details, or in some questions, they have been provided you with the more details and wanted your analysis for the answer. But this time the questions were more on the direct side. So I think this questions were clear to you. Thank you everyone. Bye.